Welcome to this lesson. So today we are going to continue with the implicit differentiation, where today we'll treat an application question of the implicit differentiation. So let's proceed. Let's look at the diagram over here, or this figure over here. We can see a certain curve that the curve is labeled or named C. So the question goes, the figure above shows a sketch of the curve C with the equation y equals x to the power x, okay, where our x is absolutely greater than 0. Find by first taking logarithms of the x coordinate of the turning points. Okay, so we have been given a hint here by first taking what? The logarithm of both sides. So let's take or see how we have to proceed with this. Alright, so let's first give a solution. Okay, so from the question, the equation y is equal to x to the power x, where definitely our x is greater than 0. Now that we know that our x is greater than 0, from the question to as well, we've been asked to take the logarithm of both sides. So here, we identify that we take log of both sides, okay? So let's just represent that with the lane. So here will be lane y should be equal to my lane x to the power x. This is a very clue enough. Now, based on the laws of logarithm, we have a certain log to a certain power. Then, whatever is raised to the power can multiply the length function. All right. For example, when I have log of maybe to base 10 as usual, or 5 to the power 2, this is the same as 2 log 5. Okay. So we are going to apply that concept at the right hand side over here. Doing that, we are going to still get my lane y is equal to x lane x. So we have to now differentiate all this. Now, how do we differentiate the length function? We want to differentiate the length function. We first differentiate the term. So a length function, let's say lane y, typically, we have to first differentiate the y, where my d dy here, maybe this is y, okay, so it will be d dy of the first term over here. So this is what? Y all over the main function, which is what? Y. So here, actually, we are differentiating with respect to x. So here is supposed to be d dx. Okay. So we are first going to take what? The d dx. So let's take that over here. So here we are first actually taking the d dx. Okay. The d dx of the function here, then divide through by what? The main function. Okay, so we are going to do or apply the same here, where we are going to have what? When we differentiate y, we know that we are going to get what? 1 and then all over my y. But mind you, this is still implicit differentiation. From the previous, we understood that when you differentiate with respect to y, you now have to multiply it with what? dy dx. You multiply it with dy dx. Now, after we have gotten this, we now have to differentiate this part as well. Differentiating the right hand side, we are also going to use what? The product rule. Why? Because the term x is also multiplying a different term x. So let's visualize this way, where if I have my x lane x, where I made my x to be my first term, my lane x to be also my second term. Okay, so let my x over here be some f, okay, where my lane x, so this be f of x, where my lane over here be what? My g of x. Okay, now that I've identified my f of x from the product rule, we identify that first we differentiate the first term, which is what? My f prime of x, then we multiply it to the second term, lane x, then we now what? Differentiate the second term, which is going to be the g prime of x, then you multiply it to the first term. So doing that, when we differentiate the first term over here, x, with respect to x, I get 1, and then multiply that with the second term, which is what? Ln x, which is ln x. Okay. Then I add that to the derivative of the second term. But when we are differentiating what? The ln, we differentiate the first term, the term over here, divided by what? The term itself. So when we differentiate x over here, so this is what? X, when we differentiate x, we get 1 over the term itself, which is 1 over x. So here I'm going to have what? 1 over x. Now this is multiplying what? This is multiplying the first term, which is x. So my first term over here is x. So we are now going to go. Let's take this out over here first. Okay. Then we can now proceed that our now new function, we are now getting what? 1 over y dy dx, which is equal to ln x plus 1 over x multiplying x. But here we can identify that the x over here can cancel the x over here. So we'll be left with 1 at the right hand side. So this is going to be 1 over y dy dx, which is equal to ln of x plus 1. Now, what is this telling us? From the question, we identify that we are going to see what find the by first taking the logarithms. Okay, the x coordinate of the turning point of C. By considering the turning point of C, this means that we need to find the slope of the curve, where the slope of the curve where the x is equal to 0. Then at that point we are going to see what? The turning point. So that is what we are going to do. Sorry, when we find what? The slope of the curve, and then where the derivative of the function is now equal to 0, the remaining points are now the turning points. Okay, so from that we are going to what? Make dy dx the subject, or equate dy dx to 0. Doing that, we can equally substitute dy dx over here with 0. So it means that our target is that our dy dx should be equal to 0. But then we can just equally substitute what? Dy dx over here with 0. Okay. With doing that, we can have 1 over y into bracket 0, which is equal to what? Ln x plus 1. And with this is still going to be the same function when we make dy dx the subject and then what? Equate it to 0. Let's try that and see. When we want to have what? Make dy dx the subject over here, we are going to get 1 over y is dy dx. Okay, this is equal to ln x plus 1. Then we make what? Dy dx the subject. This means that I multiply both sides by y. I'm having my dy dx, which is equal to what? Y ln x plus y. Now we know that this guy is 0. So 0 is equal to what? Y ln x plus y. What do? We can make what? Our y the subject over here. Making y, sorry, we can factor out y, as simple as that is. So we have y to be equal to what? Ln x plus 1, which is equal to 0. But over here, what we can also do is that we can divide through by y. When divide through by y, then we are just going to get what? When divide through by y, we are going to get 0 is equal to ln x plus 1. So doing this, we know that is the same as this function over here. So we can take this guy away and proceed with this. Now having that, we can have okay. Having that, we are now going to get my 0 is equal to what? Ln x plus 1. Now we have to make our x the subject. How can we make x the subject? It means over here, I'm going to get what? Minus 1 is equal to ln x. How can we make x the subject? We can take the exponential of both sides, where I take e to the power minus 1, which is equal to what? E to the power ln of x. Taking the exponential of both sides, we know that this is equal to e to the power minus 1, and then the exponential cancels the log over here. This means that I'm going to be left with what? X over here. It means that my final value of x over here is e to the power minus 1, which is the same as 1 over e, which is equal to x. Now we have finally deduced or gotten what? The x-coordinate of the turning point. And we know that at the turning point, the derivative of the slope of the curve is 0. Thank you.